Hello everyone, I am Javedul Ferdous, a PhD student in the Department of Computer Science at Old Dominion University, Virginia. In this presentation, I will talk about my work on improving the interaction experience with web data records for blind screen reader users. Web data records are an integral component of many websites, specifically those that present structured information by querying from a database. Examples include a list of products or services such as items on a shopping website, available hotel rooms on a travel website, employment opportunities in a job search website, and so on. Most often, in addition to web data records, the host website also provides additional support tools such as data filter, sort option, search form, and paste link for convenient interaction with the data records. These auxiliary segments are typically found scattered around the data records in a way that is convenient for point-and-click interaction with a visual input device such as a computer or mouse. As people who are blind cannot use a mouse and instead predominantly rely on a keyboard-driven screen reader assistive technology, accessing the auxiliary segment is not as easy and quick like it is for sighted users. The screen reader user must manually move the focus back and forth between the data records and the auxiliary segment using an assortment of special keyboard shortcuts. Furthermore, the shortcut patterns to access the auxiliary segments on different websites are likely to be different due to differences in their underlying HTML implementations. This limitation increases the time and frustration for screen readers while interacting with web data record. There, however, exist prior works that strive to reduce the interaction burden of a screen reader user in a web browsing, including data recording interaction. Many of these previous methods are based on speech or natural language assistance, where a user can issue a spoken or typed command to automatically move the screen reader focus to a particular screen of the web pages. While these assistants are indeed helpful, they have the same limitation as any of other speech-based systems. For example, they cannot be used in all environments. Error in automatic speech recognition has always been an issue, and so on. There are also prior works that have leveraged special purpose input devices such as Microsoft Dial or a haptic mouse to support convenient non-visual navigation of web pages. A limitation of these approaches, other than the need for additional hardware, is that a user has to switch between multiple input modalities during interaction, which can be confusing and uncomfortable at times. Given all these reasons, in this work, we pursued an alternative non-speech approach to provide the same kind of quick and easy navigation and assistance, but without the need for any additional hardware. To provide convenient access to auxiliary segments such as filter sort option, we designed a pop-up interface, namely InSupport, containing a dummy control that serves proxies to the actual auxiliary segment control present on the web pages. This pop-up can be instantly accessed with a special shortcut, and its contents are dynamically determined based on the current content of the web pages. The navigation of the control in the pop-up is uniform across all the web pages, and the user only needs to know a few basic screen reader shortcuts for this purpose. We implemented InSupport as a browser extension so that it can be provide support for any arbitrary web page containing data records. InSupport has two core components, a segment structure and a proxy interface. The segment structure analyzes the web page DOM and extracts the auxiliary segment, that is, filter, sort option, search form, and the multi-page links using custom machine learning-based identification algorithm. The content of the identified auxiliary segment is then duplicated and presented to a user by a proxy interface as shown in the figure. The user can instantly access the proxy interface using a special shortcut and then navigate the content using tab or arrow keys. All user selection in the proxy interface, for example, sort by price, are automatically translated by InSupport into equivalent action on the actual auxiliary segment controls on the web page, thereby achieving the same intended effect. We devised four separate algorithms for extracting the four types of auxiliary segments: filter options, short options, search form, and multi-page links. These algorithms all have a similar workflow. They start by first extracting all the candidate DOM nodes by referring to a predefined list as presented in the table. The predefined list was compiled after a manual analysis of 100 web pages from top visited websites belonging to different domains such as shopping, travel, job search, and classified. Then the algorithm extracts a set of hand-encrypted features from the DOM subtree of all candidates. The extracted features representing each candidate are then fed to custom-built machine learning models that use classification to determine whether the candidate is the intended auxiliary segment. To evaluate the machine learning model, we built a dataset for each of the four auxiliary segments from a common source of 209 manually annotated web pages. Since each web page contained one instance of each type of auxiliary segment, in total we had 209 positive examples per auxiliary segment type. We also randomly pick one negative data point per auxiliary segment type for each web page in order to have a balanced dataset having a total of 418 data points. For each segment type, we randomly set aside 320 data points for training and use the remaining 98 data points for testing. For training, we explore two models, namely logistic regression and multi-layer perceptron. While both algorithms perform well as seen in the table, the best performing algorithm varied across the segment types. The keyboard shortcut for navigating the InSupport pop-up interface mostly consists of basic navigation shortcuts such as arrows and tab keys as shown in the table. The special shortcut to invoke the pop-up interface was set to Ctrl plus Shift plus Z. To evaluate InSupport, we conducted a user study with 14 screen reader users who were proficient in web browsing and JAWS screen reader. The participant did two types of representative tasks on travel and shopping website. The participant did the task under the three conditions: 1. Using a screen reader only, 2. Using the state-of-art navigation assistant tool called Sail, and finally using a InSupport. The result for task complete times and the number of input sections both were in favor for the InSupport condition compared to the other two study conditions. These differences in the performance metrics were also statistically significant. Overall, in the InSupport condition, the participants limited their focus to pop-up interface and therefore spent less time exploring the web pages like they did in the other two conditions. The system usability scale scores measuring usability were significantly higher on average for the InSupport condition compared to those for the other conditions. Likewise, the NASA TLX scores measuring task workload was significantly lower for InSupport, and the rating for the individual TLX subscales was more uniform with no obvious patterns. In the exit interview, most participants attribute their favorable ratings to the instant access feature of InSupport, which they said reduced the number of key presses for navigating between web page segments. Almost all participants stated that having a separate proxy interface for accessing the auxiliary segments was important because it helped them separate their concern, that is, use screen reader shortcuts only for navigating within the data records and not worry about how to navigate to the auxiliary segments. A majority of the participants also stated that screen reader they could not explore many data records due to fatigue and therefore they often missed out on the best deal. These participants expressed that fatigue and frustration were significantly lower with the InSupport, so they can explore more data records and get better deals. In other quality feedback, 5 participants expressed a desire for remembering the past selection of filter and then automatically applying in future interaction involving the same or similar data records to mitigate duplication of effort. Half of the participants wish to have all data records in one page as distribution over multiple pages only serve to increase their interaction burden. Our work had a few limitations. First, the dataset for building and evaluating the algorithm were relatively small, and moreover, the evaluation was not performed in the wild on arbitrary web pages. The evaluation too was restricted to specific environments such as Chrome browser, English language web pages, and JAWS screen reader. Further work therefore needed to ensure generalizability of the proposed ideas, informed by study finding. Automatic filter selection and reordering based on prior user data can further reduce the interaction effort for screen reader user, so we also intend to pursue this idea in our future works. The entire project including the dataset is publicly available. I thank you all for your patient hearing.